Myers. Today we'll be having a wonderful time exploring polynomials. And if anyone would be so brave and read the standard for me. Seeing no hands? Okay.
Understand that polynomials form a system analogous to the integer, namely they are closed under operation of addition, subtraction, and multiplication, add, subtract, and multiply polynomials.
Okay, thank you. And more simplistically, can Liam go ahead and state our lesson objective?
Students will be able to multiply, add, and subtract polynomials.
Okay, so before we go into what I have planned for us today, I want to kind of remind us and give us some definitions so that we can expound upon before we actually get into math, okay? So I said we're going to explore polynomials, but in order to do so, I think we have to understand what a monomial is, and that is a real number, a variable, or the product of a real number and one or more variables. Okay. Can someone help me out and write that on the board, because we're going to need that. Okay, Quan, there you go. Go all the way down there. You just write monomial is a real number.
Okay. All right.
Yeah, you're just writing the definition.
Is it a real number?
It's a real number, comma, variable, comma, or the product of a real number
Or a product
of a real number
of a real number
and one or more variables.
and one or more.
Okay, thank you. Appreciate that. A polynomial, moving right ahead, go ahead and have a seat for me, Quan. A polynomial is a monomial or a sum or difference of monomials. Okay, I won't write that on the board, but I do have some as an example that we'll explore once we get into groups. But before I do that, I kind of want to just give a quick framing of the lesson. So we're going to do a warm-up, which I already have on the board. And then we're going to go into a group activity. Group activity. I'm writing really fast. I don't know why I got time to spare. And then from the group activity, we'll also go into another group, because I want to start us off with adding and subtracting, and then we're going to work our way into multiplying, okay? With that being said, I want to start with this as our warm-up, and we want to try our best to see the colors as equal. And what we want to do is use this model as a means to create a polynomial. Okay? So, do we notice any patterns within these three warm-up questions? Yes? Okay, do you see that there's 4 of these right here?
Yeah.
Okay, so how can we express this in a way that is correlative to polynomials?
I would say 4x.
Absolutely.
4x.
Yep, so we can go 4x, and then this is present. So like, in some instances you'll see it like this, which can indicate that we're gonna subtract. But since it's already there, disregard that x, we're just gonna do what to these? And what would that give us? No, just 5, just 5. Okay, and seeing that pattern, do we have any takers or anyone able to create a polynomial from the model that is on the board?
2x plus 3?
Yes, 2x plus 3. Good job. Last but not least, anyone?
4x.
4x. This one's a little different. This is a little different. in the aspect that these are similar, but they're different colors. Go ahead.
Would it be 4x squared plus 2x plus 4?
Yes. We just want to, there's a lot of ways that we can actually make this mean something and create a polynomial, but we want to make it the simplest for us. And I agree with that. So 4x squared plus 2x plus 4. Okay? And with that, we're just becoming familiar with polynomials. So with that being said, we're gonna count off in threes, and depending on your number, you're gonna get in your group, and you're gonna sit in these three tables, okay? So starting with Amanda, and then we'll work our way to the front. You're a
1,
2,
3,
1,
2,
3, 1.
2.
okay, so the ones right here, twos are gonna be right there. Okay, so go ahead and grab a piece of paper, please, and a pencil, something to write with. Go ahead and grab a piece of paper and something to write with. We're gonna save some trees today, but I would like for you to be as engaged as possible as we are on our way out tonight. Okay, so within these envelopes are squares. You're gonna see these squares, okay? And I'm kind of giving everyone, kind of like a leveling start, as opposed to, because the way I designed it, you can actually multiply this with that, or add, we're gonna be adding and subtracting. But I want you to focus on adding or subtracting these as they are correlated to each other. So we're not gonna take this polynomial and multiply it, or add it or subtract it right here. We're gonna focus on adding this triangle with this oval. And we're gonna focus on subtracting this triangle with this oval. And the information is within these envelopes. So one group, I'll explain to you in just a second as everyone grabs one. The first set of squares is actually not paper clipped, and that's gonna be your column here. And it's gonna be really important for everyone to have something to write with, because we're gonna show our work. And what we're gonna do, you're gonna have a triangle and an oval, okay? You can allocate that amongst yourselves, but the triangles and the ovals are gonna get the polynomials, and they're gonna work to add and subtract them. And we wanna find the product. No, we're not gonna find the product. We're gonna find the simplified version. I'm sorry, what was that?
The sum and differences of that?
Yes, there you go. Thank you for that. I appreciate that. We're gonna find the sum and differences within the triangle and oval polynomial, okay? So go ahead and, I'm sorry, I jumped ahead of myself. So there's also two rectangles. The rectangles are gonna be your sums and your differences, okay? So with this two polynomials, you'll have a sum and a difference, all the way up into this one where there will only be a difference, okay? So triangle is gonna be working with the oval to find the sum and the difference of the polynomials. And the rectangles, which I don't have showing on the board, they're gonna decipher rather if the triangle and oval use addition or subtraction. Does that make sense? Okay. I'll go ahead and let you start. I'll come around and see how we're doing. Do we have any questions? Clarifying questions? Everyone's good? All right, go ahead and start.
Yeah, 5 minutes.
5 minutes already? Jeez. Okay, we got about a minute more left. If you are able to finish before that, please let me know so we can move forward. Yep. There's gonna be a difference in the sum for every polynomial that we're.
Except for the last one.
Except for the last one. Thank you, man. All right, do we have any answers for the first two polynomials? Go ahead.
6x squared plus 4x plus 8.
6, you guys have that? And is our rectangle, yeah, when you give an answer, explain rather if they added or subtracted, please.
We added that.
Okay, next answer?
2x squared plus 2x plus 3, and we subtracted this.
Okay, we'll do this next one, then we'll jump ahead just for the sake of time, okay? And if we have any clarifying questions, I'll be after during lunch so that you can ask. Do we have the sum for the next one? For 5x squared plus 2x plus 1.
It's 9x squared plus 4x plus 2.
9x squared plus 4x plus 2, and do we have the difference? The difference?
X squared.
X squared.
Yep, that's absolutely correct. All right, so go ahead and put those away for me. I just wanted to kind of review, but yet add on to what we'll be working towards as we continue through this unit. I'm gonna hand out an actual activity where there's questions, and we'll work on them amongst ourselves, or excuse me, in groups. Can you let me know when I have 2 minutes to? All right, so the first question, we're just really gonna substitute values for D and then plug it in so that we can do the arithmetic within that statement. One thing that I know about math is that I may conclude an answer differently from the way that Ryan does, or Holly. Basically, I'm saying that there's more than one way to skin a cat in math.
2 minutes.
Okay. So I like to use each other as a support on our journey to become more acquainted with math, okay? So go ahead and stop right now, no matter where you are. We're all going to be somewhere different. But I want us to take this time to kind of explain amongst our groups the methods in which we use to solve problem number 3. Okay? And it's kind of tricky because you do have the negative that we have to distribute throughout the second polynomial. So things like that we definitely want to pay attention to because it's going to give us a different product as we're now multiplying. Okay, so enough solving. In small groups, can you share the tips or the order of operations that you use in order to come up with the answer for number 3? Using your own words. Using your own words, we're just going to explain to our groups. So that's,
Wait.
what I liked about that is that a variable, it could be an S, it could be a W, as long as we're keeping our terms within themselves, we'll be okay.
Round of applause.